Are you a first year student who has just come across the concept of taking off? Not this kind of taking off. The kind of taking off I'm talking about is the one that involves using specialized paper called dimension paper, or dim paper as we called it in university, which is used by quantity surveyors to record dimensions from construction drawings in a systematic and structured way. Maybe you're still battling with how to lay out your descriptions and your dimensions, or perhaps you understand the basics but want to level up your understanding. Either way, this video is for you. Hi there. Welcome to the Quantity Surveying Fundamentals with me, Onalinna Marumo. Back when I was in university, I was a student assistant helping my QS lecturer mark QS scripts for first years and second years. And this experience made me realize that a lot of the students did not fully understand the use of dimension paper. Some students would confuse units, right? Recording measurements meant for square meters as meters only, and others lost marks over small things like crossing out errors messily and forgetting to apply timesing factors. And I understood because I had been a first year student myself before. And working on dimension paper is tricky and confusing, especially when you're starting out. And to be transparent, I'm going to show you some of my work, first year work. This is how I entered my dimensions on dim paper in my first year. So we were doing mensuration, and these were some of the first examples that we did. And as you can see, I was recording the timesing factor in the wrong column. I mean, I was just the first year student. I was starting out and I didn't know anything about laying out dimensions on dimension paper. So I really do hope that this video is helpful to you and does contribute in a positive way in your learning journey. By the end of this video, you will be able to understand the different columns on dimension paper, correctly set out your dimensions in the correct unit of measurement, and know how to apply the timesing factor and when to apply it. Let's get started. A typical dimension sheet is split into two identically ruled parts, and each part consists of 4 columns, as you can see on the screen. This is part A, and then this is part B. The first column is what is called the timesing column, and it is used when multiplying a set of dimensions by the number of times it occurs. And then the next column is the dimension column, and it is used to record measurements as scaled from drawings or taken directly from site measurements. It typically includes length, width, height, or other relevant dimensions required to calculate the quantities of work. The third column is the squaring column, and it is used to record the final calculated quantity based on the measurements entered in column 1 and column 2. The fourth column is the description column, right? And this is where you enter the description of the work or item you're measuring. The one important thing to note is that the way we describe work is influenced by the appropriate measurement guide. For example, in South Africa, our takeoff follows the standard system of measuring building work. In other regions, they might use different guides like the NRM in the UK or others depending on the country. One of the things that we also accommodate in the description column is the waste calculations, right? And these are recorded on the right-hand side of the description column below our descriptions or the item of work that we are measuring. I do give an example of waste calculations later in the presentation. Depending on what you're measuring, there are different ways to record your dimensions on the dimension paper. So for linear measurements, which is normally your corners or your skirting or your pipe work, we use meters, and that is how you would enter a meter measurement in your dimension column. In the third column, we have squared our dimension. There are items that are measured in square meters. For example, your floor covering, your paint, and also your ceilings. These are measured in square meters. So we will have 2 dimensions in our dimension column, right? And then when we square that, it gives us a product of 20. We also have items that are measured in cubic meters, and these include excavations, concrete, or backfilling, right? So you'll enter 3 dimensions in your dimension column. And then the next example there is number. This is used when you are measuring your windows and your doors or sanitary fittings. And then the last example is item. So the unit item is used in a dimension paper when the work cannot be measured in standard units such as meters, square meters, or cubic meters. So instead, we describe the work that is to be done, right? And then in our dimension column, we put the term item. Examples of such work include site establishment, testing and commissioning, keeping excavations free from water. Let's take a base measuring 0.6 by 0.6 by 1.5 meters deep. I want to show you how the dimensions for the excavation of the space would be laid out in your dimension column. Now, since we're dealing with excavations, the unit of measurement is cubic meters. That means in my dimension column, I'll have 3 dimensions for this item of work. Now, the dimensions will be recorded in the dimension column in the following order. We start with the length first, so that would be 0.60, followed by the width, which is 0.60, and then the last dimension will be for the depth, which is 1.50. And that is how you would enter your dimensions in your dimension column. Waste calculations. Not that type of waste. The waste I'm talking about is the one that we record on the right hand side of the description column in our dimension paper. These calculations basically show your train of thought and how you arrived at the answers. Like in this example, the waist calculation here shows how the gable height of 0.94 was worked out. It is important to write these waist calculations neatly so that one is able to follow your work and understand your train of thought, right? So you don't write them down as if you are writing on scrap paper. So now with similar items, when an entry on the dimension paper is followed by a similar item, we use the word ditto instead of repeating the same description. In this example here, the first item described is 3mm patterned glass in paints exceeding 0.1 square meters and not exceeding 0.5 square meters, fixed to steel frames with putty. The next description simply states ditto, but exceeding 0.5 square meters and not exceeding 2 square meters. Here, ditto is used to repeat the previous description, meaning the glass type, the thickness, the fixing method, and the frame remain the same. The only change is the pane size, which is now between 0.5 square meters and 2 square meters. Alterations to dimensions. When you realize you've recorded dimensions incorrectly, right? The first rule is to avoid using Tipex or making untidy corrections, right? Instead, there are 2 acceptable methods for amending errors. We were never taught this first method when I was in university, and the only method that we were taught was to write nil in the squaring column to indicate that the dimension has been cancelled and it is to be omitted. The second method is to neatly cross out the incorrect dimension and write the correct one above it. Both methods ensure clarity and help maintain a tidy record and making it easier to understand the changes made, right? Timesing. So timesing simply means multiplication, right? In the dimension paper, the timesing figure is recorded in the first column as shown in the example and separated from the actual dimensions by a diagonal stroke. In our example, we have 3 bases, each with a footing measuring 0.6 by 0.6 by 1.5 meters deep. Right. Instead of repeating the measurement 3 times, we use the timesing method, right? So we multiply our dimensions by 3. The squaring column, which is also known as the working up column, contains the final calculated quantity based on the measurements recorded in columns 1 and 2. And this is where all calculations are completed and the final total quantity is written. It is double underlined to indicate that it is a final value that will be transferred into the bill of quantities. In the example shown here, we have squared the three bases, each measuring 0.6 by 0.6 by 1.5 meters, and that gives us a product of 1.62 cubic meters. Ending on is used when two or more descriptions apply to one measurement. Instead of repeating the measurement, we simply add and list the next description below it. And this is an example of how you would use ending on. Instead of rewriting the measurements, we just simply add and backfill into trenches and holes with excavated material from the excavations to refer to the same measurements. Deduct. Now, when we deduct something, the procedure is to write the abbreviation DDT above the description against the left-hand side of the description column. It shows that we are subtracting a portion of the work we've already measured, right? Now, to demonstrate a deduction, we will use the same concrete base example as before. Our concrete base measures 0.6 by 0.6 by 0.3 meters thick. Now we will deduct the backfill that was previously measured as part of the excavation by writing DDT above the backfill description. This tutorial does not cover the exhaustive list of guidelines when working on dimension paper, but it should give you a solid foundation to build on. That's a wrap on today's tutorial. Catch you guys in the next one.